We're in Algebra 1, Lesson 9-3. Today's date is January 31st, so write down the date, 1/31. All right, so equivalent systems of equations. This is heavily based on yesterday's lesson on trying to manipulate equations. So there are essentially two different things that will make the answers stay the same. I can either multiply or add / subtract. Usually in terms of the homework tonight, everything is adding. So if you want to just underline adding, that's the one that you really need to understand. Subtracting, I've done 10 problems on Khan Academy just to test it out for you guys, and I've never seen a subtracting problem, but there might be one. So just know that that is technically under that category. So what do I mean by multiplying? This is what we saw yesterday. If I multiply the top equation by some number, I'm just going to randomly decide, I don't know, someone shouted a number between 1 and 5.
5. 10.
5. All right. I can multiply by 5, and I get an equivalent equation. I get 15x minus 10y is equal to 5. These two equations are basically the same thing. This has just been scaled up by a factor of 5. So if I have this equation and I have this second equation that hasn't been changed, you will still have the same answer. Just by multiplying this top equation by 5 does not change the answer. I can multiply the bottom equation by another number and it still won't change the answer. Multiplication does not change the answer, which hopefully is the case because we've been doing that all of yesterday. Hopefully it's not changing the answer by multiplying both sides of the equation. So far so good. Multiplying does not change the answer. Everyone nods their heads. Technically you can say dividing as well, or you can say multiplying by a fraction. So you can say sometimes multiplying by 1/3 is kind of like dividing, I guess, but multiplying and dividing technically don't change the answer. Let's talk about number 2. This one is a little bit harder to see. If you add or subtract the equations and create a second equation, or if you add 2 equations and you come up with a third equation, that's the correct way of saying it, that also does not change the answer. So, for example, let's add these 2 equations together. I need a participation card. Who still has their participation card that wants to answer this one? I need to add these 2 equations together as if I went a giant plus here and I add straight through. Sergio, go for it.
Negative 2x.
Negative 2x
Plus y.
plus y equals to 8. So, yes, thank you, Sergio. You can turn in your card. Class, Edgar's gone. Edgar's gone. Sergio's here. He got XP. You're in the custom basket. I'll do the 3 warm-up people in a sec. So, what this means is go ahead and box these bottom 2. If I randomly chose those 2 equations, they would have the same answers as if I did these top 2 equations. It doesn't matter because I still have 2 equations that are slightly different. I didn't multiply, I just added in this case. The green box has the same answer as the orange box. In fact, I can even say same answer. This box and this box have the same answer just because I added. And again, hopefully that makes it clear that we're still okay because we've been doing that yesterday. We haven't been changing our answer just by adding equations. You had a question, Sergio? Oh, okay. All right, so let's look at an example 1. Co and Jessica, do you two want to read this at all?
Me, I'll read it.
Jessica, go for it.
Cohen and Jessica's teacher gave them a system of linear equations to solve. They each took a few steps that led to the system shown in the table below.
All right, thank you. Jessica, you can turn your card. All right, so this is the one that the teacher, I guess Mr. Sindel, is giving Cohen and Jessica. I started out with this system. I want to see which system between Cohen and Jessica has the same solution as my original system. So I need to test, are both of these equations, can you somehow find both of these equations by either multiplying or by adding? So let's check them. Those are the only 2 things I can do. So let's look at Cohen's. 4x plus 10y equals 6. Did this somehow come about by either multiplying or adding? Does someone see it? Quiet raised hand if you see it. From the original equation, did one of these 2 equations change into this equation? Gunnar.
Multiply the top equation on the he did multiply it by 2.
Yeah, so this was equation 1. We'll call this equation 1 and equation 2. This was equation 1 times 2. So that one works out. You can give it a giant check mark. You don't have to do any math here aside from the mental math in your head. I know how to multiply by 2 in my head. I'm good. I don't need to write anything down. All right. So thank you, Gunnar. You can turn in your card. All right. What about the second equation? Was the second equation, is that one of these two equations multiplied or added or the same? What is the second equation? Julian. It's the second equation. It hasn't changed. That's equation 2. Thank you, Julian. Which means the answer here is Cohen has the same answer as this system for the teacher. These two are the same. So it could be either A or it could be C, but it's definitely not B or D. Cross off B and D because Cohen definitely has the same answer as the teacher. Now let's check Jessica's. I need a quiet raised hand. Is this first equation either the original, multiplied, or added of these two equations? You have to check all three of them. Is it the original? Okay, well, neither of these have a negative 4x, so it's not the original. Did I multiply? Well, maybe I multiplied that by negative 2. Okay, not there. Maybe I added them. I don't know what's going on. Josie, add them. Add 1 and 2. So if I add 1 plus 2, let's check it out. 2 plus negative 6 is negative 4, okay. 5 plus 3 is 8. 3 plus 4 is, darn it. You see that? 3 plus 4, it should have been 7 there, yeah?
Yeah.
So it was almost add, but this number, let's go ahead and just circle it. That number was bad. If one number is bad, that makes the whole problem bad. It's not that one. 2x plus 5y was equation 1, but because I made that tiny little error, Jessica, sorry, you made this error. If you made that tiny little error, you suddenly have a different answer, so the answer here is A. Only Cohen. Cohen has the answer. I always pronounce that H way too much. Cohen. Yeah, good job, Josie. You saw that it was added, but that tiny little mistake at the end too. I'm going to give you the full XP for that, and you can turn in your card. Boom. All right. Let's move to example 2, or on the back. Sergio or Monse, you want to read this one? All right, go for it, Monse.
Sergio and Monte's teacher gave them a system of linear equations to solve. They each took a few steps that led to the system shown in the table below.
All right, so it's basically the same setup. Thank you, Monse. You can turn in your card. It's basically the same setup. Now we have to check both of these equations to see if they're the original, if they've been added, if they've been multiplied. So I need to label this, I'm going to call this equation 1 and equation 2. So I need to look at this first equation that Sergio has. Where did that come from? Quiet raised hand for someone that still has their card. Where did equation 1 come from? Did you add? Did you multiply? What was Sergio trying to do at least? It might be wrong, but what did Sergio try to do? You can see it's either a combination of these two equations. You either add these two, multiply one of them, or it's the original. It's going to be one of those 3 options. Who sees it? That still has a participation card. I have 9 cards in, which means there's still 3 cards out there. There's a teacher error? Oh, dang it. I just copied and pasted it, and oh, gosh. All right. Oh, man. Oh, man. Okay, we need to change these out. This is what happens when you copy and paste. Sergio was the first person to officially find it, so he's the one that gets the XP. This should be Sergio. This should be Monse. This should be Sergio and Monse. So.
You said after me.
No, sir.
And Monse.
And me.
This should be
Always said after me.
Sergio nor Monse. All right, Sergio gets it. He caught it first. Be the first to catch it next time. Log it in your extra credit tracker too.
It's not.
I'm going to go find another one.
Oh yeah. All right. So yeah, that is an incorrect problem. But what did Sergio try to do for this first equation? Can you see what he did? What was he trying to do? Gunner Hood. I'll give you a hint. Look at equation 2. There should be 2 people out here. I guess I'm going to have to cold call on one of them. I'll sign it later. So Julian's participated. So it's going to be either Fernando or Jennifer, I think. You already have your card in? Who still has their card? All right, Fernando, tell me.
Okay. They added.
To get, what did they add? These two together to get 2x plus 14 plus or equals 16?
No, negative x plus 11y.
Oh, so this one was added. So 1 plus 2 right here. 1 plus 2. All right, let's check it. So if I add 1 plus 2, negative 2x plus x is a negative x. Good. 4y plus 7y is 11y. Good. 5 plus 8. Oh, darn. All right, everyone circle this. Aye, Sergio.
No, that's true.
Sergio made a mistake. It should have been 13 here, so this one is wrong. But let's check this first equation. Let's check this first equation. Obviously, if that one's wrong, then Sergio has a different answer. But I just want it for the sake of practicing. What was this first equation? So Fernando's in. Cohen, you're doing the next one. Wait, sorry. This is Fernando that participated. Boom. Where did this first equation come from? Cohen? I did something to equation 2. X went to 2x, 7y went to 14y, 8 went to 16. What's the commonality? Yeah, you multiply the second equation by 2. No, you have to let him do it next time. Yes, you have it, Cohen. We multiplied equation 2 by 2, and is that correct? Let's see, 2 times x, 2x, 2 times 7y, 14y, 2 times 8, 16. That one was good, but because one of them was bad, Sergio does not have the same answer. All right, so let's look at Monse. Everyone can participate multiple times now. Did I give Cohen his? I did, okay. Let's look at Monse's answer now. Where did x plus 7y equals 8 come from? Quiet raise hand. You can participate multiple times now. Everyone can raise their hand. Jose. Oh, it's just the copy of the second equation. Yeah, thank you, Jose. What about the next equation? Negative 6 plus 12y equals 15. Where did that come from? Monse.
I used equation 1 multiplied by 3.
Multiplied by 3. Let's check that. So 3 times negative 2x, you got negative 6x. 3 times 4y is 12y. 3 times 5 is 15. All right, yeah, so this is equation 1 times 3, and all of it was correct. Give them both check marks. All right, so thank you, Monse. Monse is checking her own work because that was Monse's work. All right, what's our answer? E, F, G, or H? Quiet raised hand. E, F, G, or H, if you change them appropriately. E, F, G, or H, Fernando. It is indeed F. It was only Monse. Only Monse. All right, that concludes the notes. Go ahead and write your summaries now. Basically, there are 3 different options, right? It's either the same, you either multiplied, or you added. It's the same, 1, or 2. That should be in your summary.